Welcome to another OnRamps Physics 2 demonstration now of thin film interference. Remember, interference is when we combine two or more waves, and if those waves combine in phase, so they're maximum together, they add constructively to give a more intense wave. And if those waves combine out of phase, destructively, they will cancel each other and give a less intense wave. So in thin film interference, we're interested in light striking a film and reflecting typically, and the reflections, or the two waves, are the light reflected off the top surface and the back surface. And these have some path difference. And so when that path difference is enough for constructive interference, you'll get bright spots. But remember one other feature: there's a phase change upon reflection when you reflect from a more dense medium. So this top ray off this outer surface is inverted, while this back ray reflecting off of a less dense medium on the other side is not inverted. So let's take a look at this. We have white light coming out of a projector, and it's going to bounce off a thin film that I'll put onto this rectangle. And at first, you'll notice you see many bands. There's green, red, with some intermediate colors repeating over and over again. And at the very top, it seems to get dark. And if we wait a few minutes, this pattern will evolve. And maybe we should turn out the lights to get a little better picture of that. All right, so what's going on? Well, there are this soap film is hanging in that rectangle, so it tends to be thin at the top and thicker at the bottom. So the path difference that for reflected light is changing as we go throughout this film. And if the thickness is just right, the wavelengths of red light constructively interfere upon reflection, we'll see a red band, or a green, yellow, or orange, or blue band. Of course, when this is used in practice, we typically make the film a uniform thickness so that only one reflection occurs. For example, on camera lenses, we put coatings so that light is not reflected, but instead most of the light will get in through the lens. So we make that thin film destructively interfere to encourage all the light to get into the lens and not to be reflected, sort of as in some of the darker regions here.